Please welcome from Palantir, Ted Chester Jenks and Matthew Bayer.
Thank you, everyone, for joining us. We're going to talk to you a bit today about how you can optimize data pipelines in Foundry with some of the newer features that we've been working on. Specifically, we're going to take a look at Iceberg tables and lightweight transforms. Before we get into that, I'm Ted. I'm a group engineering lead in our data plane group in Foundry.
And I'm Matthew, a developer on our compute engines team.
So we can break our data platform down into three main columns of features. At the center, we have our orchestration and governance features. These are things which historically Foundry has been incredibly strong at. So you'll all be familiar with a lot of the sort of scheduling functionality that we have, the data lineage through which you can view your enterprise pipelines. And of course, we take security very, very seriously. In addition to these features, we have storage and compute. And a lot of the work that we've been doing recently has focused around making these as flexible, modern, and modular as possible. So on top of the things which a lot of you will have experience with using, our core dataset, stream, and media set primitives, as well as our compute with Flink and Spark, we've opened up new modalities in both of these spaces to make things more flexible. The first thing I want to touch on is Iceberg tables. The big headline news here is that we're migrating native Foundry datasets to use Iceberg. This is a feature that's currently in beta. We have it testing on a few stacks right now. And so to get going, let's talk a bit about what Iceberg actually is. So Apache Iceberg is an open source project. And at its core, it defines a table specification. A table specification is a metadata layer that lives just above your data file format. So in your data file format, which is typically Parquet, you have your tabular data stored. We care about a lot of information in addition to that. Things like schema, branches, and transactions all fall into what we call table specification. Traditionally, these things have been managed with a proprietary system in Foundry. The innovation of Iceberg is to do it in a standardized and open way. This makes your data completely portable and interoperable between different platforms and compute engines. In addition to this table spec, and really critical to the success of Iceberg, is the catalog specification that's also specified within the framework. A catalog is a server that can serve information about your tables, crucially where they're located. And in Iceberg, there's simply a REST API that you can implement. And as long as you're compliant with this, then all of the Iceberg clients will be able to read your data. For us, this is a place where we can plug in all of our proprietary concepts, so things like Foundry governance, things like Foundry metadata, and of course, all of the sort of version control is managed in this layer. The final thing that we get from Iceberg is the clients. So Iceberg provides a bunch of open source clients in different languages and compute engines, which can be used to easily read your data. Some of the ones you may have heard of are PyIceberg, which allows you to read Iceberg tables from Python, as well as the connectors that exist for engines such as Spark and DuckDB. So that's an overview of what Iceberg actually is. I suppose the next question is, why should you care? Well, we get a few key benefits from introducing Iceberg in Foundry. First and foremost, there are huge performance upsides. Early benchmarking showed around a 30% performance improvement on the industry standard TPCDS benchmark, thanks to the advanced partitioning schemes that Iceberg uses, as well as its metadata management. In addition, it unlocks features which previously did not exist in the platform. Namely, it unlocks in-place row-wise edits and deletions while maintaining downstream incrementality. This is something that wasn't previously possible due to the way that metadata was stored in Foundry tables. And it meant that in order to perform these kind of workflows, which are typical in things like CDC, you had to re-snapshot your entire data set. Another feature that's unlocked with Iceberg is table compaction. So this is the rewriting of many small data files into fewer larger files. It's an optimization that improves the performance of downstream reads as it reduces the I/O overhead incurred in reading the dataset. Finally, and as I already alluded to on the last slide, it gives us great interoperability. This is true both for external reads, so if you're reading from another platform or maybe in a local session, but it's also true within the platform. It makes it much, much easier for us to pick up the latest and greatest tech when it comes to different compute engines or different frameworks, as connectors exist in the open source community and don't have to be built from scratch every time. We've done a bunch of work to make our implementation of Iceberg best in class. So the central column that you see on the slide here refers to some of those features that we're particularly proud of. Our branching implementation goes above and beyond what exists in the open source community and essentially gives you the full feature set that you'll be used to with Foundry datasets today. This is a very mature and Git-like version control system. We've implemented schema evolution that allows incremental transforms to change the shape of data over time without having to replace or re-snapshot your dataset. We've expanded the concept of transactionality that exists in Iceberg and made it more robust, reducing the amount of conflicts you get from parallel writes on the same dataset, which ultimately saves compute, as our testing showed that these conflicts meant you got a lot of failed jobs and a lot of rerun compute. And finally, we've worked with the open source community to get double encryption included in the spec. Implementation for this is still being built out in the open source, but the headline is that on top of the encryption, which you get from your cloud provider, keys can be stored locally and an encrypted client-side, reducing the single point of failure in the case that a cloud provider gets compromised. On top of these table features, all of the existing data platform features that you'll be used to in Foundry will continue to work on Iceberg datasets. So things like code provenance, being able to jump into the code repo that your dataset came from, data lineage, being able to view your full enterprise pipelining, version level security, and then maintenance tasks like retention will continue to work. So based on that last slide, I'm sure all of you are desperate to get your hands on this and will be eager to find out how that's possible. As I said, we're in beta, and the answer is to come and chat with me. I'll be here for the next 2 days. I can give you my email. There's some eligibility requirements at this point, but we can have that discussion. I'd be particularly interested in hearing from you if you fall into one of the following 4 categories. So if you've got really large-scale data where you're hitting performance issues, if you have data sets that have lots of small files and that's causing downstream reads to be expensive, if you have use cases that would benefit from row-level edits or deletions, or if you have use cases that would benefit from interoperability, so maybe you want to read data externally in another platform or locally, then please reach out. So that's the sales pitch over. I want to show you now what we were able to achieve in production by deploying Iceberg in Foundry. In this particular case, we had a single data set that was over a petabyte in size, so pretty big. It was made up of millions of files, and it was continually growing. This was an ingest of data from an external source, and it was building every few minutes or so. The result is that the file size optimization was very, very poor. There were loads of small files, and downstream reads were incredibly expensive. In addition, there were cases where in-place row-level edits or deletions were needed due to erroneous data, but this simply wasn't possible. The only way to achieve this would have been to re-snapshot the entire dataset, so to rewrite a petabyte of data, and that was simply prohibitively expensive. A final point is that interactive analysis in apps like Contour was getting pretty slow, as you can imagine. So the solution, of course, it won't surprise you, was to migrate this entire pipeline over to use Iceberg tables. The first and probably most important thing that this gave us was the ability to run automatic compaction. You can see that we reduced the file count by 99%, and the performance implications of this were drastic. The Slack message here is a testimonial from a downstream consumer who had a pipeline that was taking 2 hours, and after that 2 hours, the build simply ran out of memory and failed. After the migration, they were able to execute the same pipeline in just 2 minutes. This is also thanks to things like the metadata management that Iceberg uses, so some of those performance characteristics I alluded to earlier. And on top of these performance benefits, we were able to now do row-level edits and deletions in place, so that workflow that was simply blocked before became possible. And downstream interactive analysis in apps like Contour was way, way easier, and this became a much more productive workflow for all the analysts who relied on this data. So that about summarizes what I wanted to talk about with Iceberg tables. And that speaks to what we're doing in the platform with our native data storage to improve interoperability and to modernize the platform. I want to just quickly point to the fact that we're doing things beyond this. So in many cases, you may have existing data that's stored outside of Foundry in other platforms, maybe BigQuery or Snowflake or Databricks. For these, we have virtual tables. So this allows you to read data from external sources and to use Foundry as if it's a native data set. We basically want this experience to feel completely analogous to if your data lived within the platform. With that, I'm going to pass over to Matt, who's going to talk to you a bit about compute.
Great, thanks, Ted. So as Ted had discussed on the left side of this slide, we've made a number of interoperability investments in flexible storage. So this means storing data in traditional Foundry data sets, as Iceberg tables, and even outside the platform. We have parallel investments for flexible compute. So whereas traditionally you may have experience writing Spark pipelines within the platform, we have a number of different options that we're actively investing in as time goes on. So I want to touch on the fact that we have federated compute, which allows you to push compute down to other platforms like BigQuery, Snowflake, or Databricks. But today we're going to focus on lightweight transforms, which is our in-platform offering for flexible compute. You can see there we have a couple different runtimes under lightweight, Polars, Pandas, and DuckDB. We're going to chat about those as a way to provide more flexibility into the runtimes and query engines you're using in your transforms in platform. So just to back up before we talk about what lightweight transforms are, I want to highlight why it's important now. So one key thing we've seen in the open source community is that the compute ecosystem is changing. Whereas beforehand, many pipelines of many different scales would have to be handled in a distributed framework like Spark, we've seen an explosion in the number of highly efficient, modern query engines on the market today. So I have 3 of them up on the slide here. We have Polars, DuckDB, and Apache Data Fusion. These are all highly performant, modern, single-node compute engines that are blowing away benchmarks. So I've also copied over some of the key features that they like to advertise on why you should use their query engines. I want to highlight that there's a couple similarities. So first, they're all written in native languages. For Polars and Data Fusion, that's going to be Rust. And for DuckDB, that's going to be C++. This is important because it allows your pipelines to fully leverage the hardware at hand, whether it's something like parallel vectorized execution or more efficient memory management. The second feature that all these runtimes highlight is an efficient streaming engine, which means you don't have to load your whole data set into memory. This allows you to run very lightweight profiles against very large data sets, often operating on data sets that are much larger than memory, since you never have to hold the whole thing at the same time. So how do we leverage these modern, highly performant, single-node compute engines within Foundry? That's where lightweight transforms come in. So what are lightweight transforms? It's a simple way to provision single-node compute within the platform for pipelines of small to medium size. So I want to highlight some of the key things we've seen here as we've experimented with them internally and out in the field. Again, we've seen that lightweight pipelines can be highly scalable and performant, mainly owing to the query engines they're running under the hood. We have first-class APIs for Polars, DuckDB, Pandas, Arrow, and a few others that are growing all the time. And we've seen these scale to pretty large data scales. So you can reliably process tens of gigabytes, and for some pipeline shapes, even go into the hundreds of gigabytes and terabyte scale on a single node. You're going to get full feature coverage for lightweight transforms, as you would with traditional Spark transforms within the platform. So things like incremental, handling media, handling external connections. We're at parity between single node lightweight and your traditional Spark. You're going to see efficient memory usage in a multi-engine scenario. So what that means is you can bring in whatever compute runtime you'd like as a Python package or as your own container that you'd like to run in a single node. And leveraging the streaming compute and native engines that we were chatting about before, you're going to see that you're able to process data of unprecedented scale with a very low resource profile. And finally, I want to touch on the fact that we have modern IDE support as folks navigate either writing pipelines in a new framework that they haven't seen before, or migrating old pipelines to a new framework for the efficiency gains. So what do you get here? Well, we have a modern VS Code environment. You can run it either within the platform or locally and push up to your code repository. And this also comes with the Continue extension, which is an LLM assistant that has access not only to documentation about transforms, but documentation about the framework you're using, which is going to help you both migrate and author pipelines, as well as optimize them if you have a better rewrite that you could do. So where are we at with lightweight transforms today? Well, we have two separate lightweight offerings within the platform. If you're familiar with Python transforms and pipeline builder, we have them both. So for Python transforms, this is GA, and in fact, the default within the platform. So you can see we're calling @transform.using within the Python decorator. What that does under the hood is you start writing a lightweight, and you're going to have a single node provision to you. It's totally configurable, so you can request an exact amount of memory and compute to the transform you want to run, and you're off. We also have an offering for Pipeline Builder in beta. This is pretty neat because it's a low-code scenario, so we can translate your Pipeline Builder to run in Spark or on Lightweight. It's dead simple. We have a drop-down, and you just have to click Convert to Lightweight Pipeline. What this is going to do is move you off of Spark and move you to a single node running Data Fusion. So we're going to chat about a couple use cases we've seen with Lightweight and some of the gains we've had. Actually, we're going to go slightly different order. We're going to build a lightweight Python transform together. This is going to be notional. I really want to just highlight how flexible this environment is, especially if you come from an environment where you're tied down to just writing Spark or just writing some framework. We're going to go through with an example input and just build up in a slightly overly complex but very flexible pipeline here. So you can see at the top, we're defining a transform. We're just specifying an input and an output and putting that @transform.using decorator on top to define a lightweight Python transform. Next, it turns out this table is actually an Iceberg table, as Ted had been discussing before. So we're going to read it in as Iceberg and scan it in. We can then pull in pandas if we choose, if it's advantageous to the scenario, convert our Iceberg table to pandas, and perform some computation on it. Maybe we're a fan of DuckDB. Well, we can read it in as DuckDB and query it. Maybe we're a fan of polars. We can read in that data set as, within polars and perform native polars computation on it. And really, I want to highlight the decision of the runtime is pushed to the user. So if you have a shape of pipeline that's optimized for some specific query engine, you can bring it in. Or if you're familiar with authoring in a framework, you can bring that in as well. So finally, we're going to take our polars data frame, convert it to Arrow, and write it back to Iceberg. So now, no production pipeline would be written like this with 4 or 5 different runtimes, but I just want to highlight that you can do whatever you want. And again, you can bring in arbitrary Python packages if you want to process in your own way, and even bring your own images if you don't want to run Python at all. So we've seen tremendous adoption of lightweight transform in the field. We've been using it internally in some of our internal managed pipelines, as well as working with customers to migrate legacy expensive Spark pipelines to lightweight. I just have highlighted some testimonials from customers and internal devs alike. And we've been seeing some results that are a little bit too good to be true. We've seen a number of pipelines that are both faster and more resource efficient. So the gains come from a bunch of places. First, we've seen a bunch of places where these runtimes are just faster than Spark. The second thing is, in a single node compute scenario, you're dropping the overhead of running distributed compute. So you're no longer serializing data between nodes or waiting for executors to spin up, and you get the advantages there. When you combine this with the fact that over time, hardware is getting cheaper, memory in particular is getting cheaper, and you're allowed to provision much larger single nodes within compute providers like AWS, Azure, or GCP. This opens up a whole new world where you can process ultra-large data sets within lightweight transforms within a single node and run within these highly efficient native frameworks. So I want to zoom in on one internal pipeline that we optimized. So we have a data set internally at Palantir, which handles events about jobs. So for a number of jobs around the fleet, we just record, like, did jobs fail, when did they run, and the such. So we often query that in cases like bug fixing and performance analysis, and we used to do that with Spark. So this data set is around, it's on the scale of tens of terabytes, but for the particular query we're interested in, it's, again, 5 billion rows of input and 240 million rows of output. We can see on the bottom, we used to run this with Spark. The aggregate compute runtime was a day and a half, so this is quite expensive and quite slow. we recently migrated this pipeline to Polars, and we can see the total compute usage went down to under 2 hours. So it's both faster and cheaper. I want to zoom in a bit on LLM translation here. So a lot of folks, when dealing with lightweight transforms or new frameworks, are concerned about either the education costs of getting upskilled in a new framework or migration costs. What I have here is a multi-100-line Spark transform. On the left, I've just said, convert this to Polars, please. Under the hood, the agent is smart enough to say, hey, Polars can be run in lightweight, so let's convert this Spark pipeline to lightweight, and then it goes off. So we've seen a number of cases where an LLM can completely one-shot pipeline translations, and the only human input is in review. And we've seen an even larger number of cases where it can get you 90% of the way. So it can keep you up to date with the Polars API or whatever runtime you want to use, and then just have the human finish the last bit. So it's been a tremendous efficiency improvement as well. That's all I have for lightweight. Unless you have anything else, Ted, I'm super excited to share these features with you, and even more excited to see what you build.
Yeah, with that, I think we have some time to take any questions you all have.